Hello everyone, welcome to my chemistry concept channel where I would cover lot of areas about chemistry with proper explanation, and the perception and conception about chemistry would be crystal clear if you follow my channel properly. Today I would cover Bohr's atomic model. This is very much included both in West Bengal Board and ISC Board class 11. Bohr's atomic model is really very important in chemistry also because electrons revolve around the nucleus in a fixed circular path, what are called orbits, shells or energy level. These orbits are called stationary states of energy levels. The word stationary does not mean electrons of these orbits are stationary. Rather, the energy of the electrons remains fixed. It does not change with change of time. So long as electron does so, there is no absorption or emission of energy during its motion around the nucleus. It is highly contradiction in classical electromagnetic theory. As postulated by Bohr, these energy levels are designated as KLMNO cells or numbered as 1, 2, 3, 4, etc. Normally, nucleus in an atom always situated at the center, and around the nucleus first K cell will come, then L cell will come, then M cell will come, thereafter N cell and O so on. According to the energy level, these cells are arranged. The lowest energy level of the electron is termed as ground state level. Change in energy occurs whenever electron moves from lower to higher cell by way of acquiring required energy. At the same time, whenever the electron jumps from higher to the lower energy cell, then it must lose energy. In connection with Bohr's atomic model, the energy absorbed or emitted is equal to the difference between the energies of two energy levels, that is E2 and E1, and is determined by Planck's equation, that is del E is equal to E2 minus E1, where del E is the energy absorbed or emitted, H is the Planck's constant, and V is the frequency of electromagnetic radiation emitted or absorbed. Now I will explain the distribution of electrons in orbits or shells, how it can be calculated. That is, the most simplest formula is 2n square. N is the cell number. In case of K cell, that is 2n square, where n is 1. That is 2 into 1 square means it can accommodate or hold maximum number of electron is 2. L, where n is equal to 2, 2n square means 2 into 2 square, that is it can accommodate or hold maximum number of electrons are 8 in the L cell. In the M cell, where n is equal to 3, 2n square means 2 into 3 square, that is 18. It can hold maximum number of electrons. And in case of n, where n is equal to 4, 2n square is 2 into 4 square, that is it can hold maximum number of electron is 32. The angular momentum of an electron revolving in energy cell is given by MEVR is equal to NH by 2 pi, where N is the number of corresponding energy cells, that is 1, 2, 3. Me is the mass of electron, R is the radius, V is the velocity, and H is the Planck's constant. In connection with Bohr's atomic model, now I would discuss about the difference between cell and subshell. What is cell? Cell is the path of electron to go around the atom's nucleus. There are several cells around an atom having different energy levels. The cells are arranged in their increasing order around the nucleus. The cells having least energy comes first, and with the highest energy is farthest from the nucleus, such as K, L, M, N, etc. Each cell can hold a number of electrons that are based on its principal quantum number. Its formula is 2n square, where n is the cell number. What are subshells? Subshells are named according to their angular momentum quantum number. Thus, there are 4 kinds of subshells in a cell, S, P, D, F. The S subshell has the lowest energy, followed by P, D, F. They also have specific structure. The S subshell has a spherical shape, while P has a dumbbell shape and D has a double dumbbell shape. The characteristics of subshells are: subshells are distributed based on the azimuthal quantum number, which is denoted by L. Each cell are again divided into number of subshells. There are 4 subshells S, P, D, F. For example, the first cell consists of only one subshell, that is S. In the second cell, there are 2 subshells S and P. In the third cell, there are 3 subshells S, P, D. The rest of the cells consist of all 4 subshells S, P, D, F. A subshell is the set of states defined by azimuthal quantum number L within a cell. The values of L is equal to 0, 1, 2, 3, corresponds to S, P, D, F subshells. The maximum number of electrons which can occupy a subshell is given by 2 within the bracket 2L plus 1. Then we come to the tabulated representation. Subshells, then L, that is the azimuthal quantum number, maximum number of electrons it can hold. Subshell S, that is azimuthal is when 0, maximum number of electrons it can hold is 2. Then P, azimuthal L is equal to 1, that is maximum number of electrons it can hold, that is 6. D, when azimuthal quantum number is 2, then it can hold maximum number of electron is 10. And F, then azimuthal quantum number when 3, it can hold maximum 14 electrons. Now I would discuss about the difference between orbits and orbital in a tabular form. First point, parameter, that is first I will discuss definition, both of them, orbits and orbital. Orbit is a well-defined circular path around the nucleus in which electrons revolve around the nucleus, whereas the three-dimensional space around the nucleus where the probability of finding an electron is maximum, it is called orbital. Second is position. It represents the motion of an electron in one plane in case of orbit, whereas in case of orbital, it represents the motion of an electron in three-dimensional space in connection with parameter, that is shape. All the orbits are either circular or elliptical, whereas in case of orbital, orbitals are of different shapes such as spherical, dumbbell and double dumbbell. Let us come to the fourth point, electron occupancy. In orbit, 1, 2 or more than 2 electrons can be present. In one orbit, number of electrons can be 2n square, where n is the number of orbits or principal quantum number. In case of orbital, in one orbital, maximum number of 2 electrons can be filled. Vector nature. Fifth point, orbits are non-directional in nature. Orbitals are directional in nature except for s orbital is spherical in shape. Uncertainty principle, that is sixth point. Orbits represent that position and momentum of an electron can be measured simultaneously with certainty, which is against Heisenberg uncertainty principle. Whereas in case of orbitals, concept completely complies with Heisenberg uncertainty principle. Seventh point, that is designation. Orbits. Orbits are represented by K, L, M, N, etc. Whereas orbitals are represented by letters like S, P, D, F. deBroglie's relationship, the examination of dual behavior of matter, was one of those developments that had profound impact on the formulation. Considering the particle nature, Einstein equation is shown as E is equal to mc square, where E is equal to energy, m is equal to mass, and c equal to speed of light. Considering the wave nature, Planck's equation is given as E is equal to hv, where E is equal to energy, h denotes Planck's constant, v denotes frequency. From equation 1 and 2, mc square is equal to hv, that is equation number 3. Frequency v can be expressed in terms of wavelength lambda as v is equal to c by lambda, since lambda is equal to c by v. For a general particle, c can be replaced with the velocity of object v. Hence, equation 3 can be given as mv square is equal to hv by lambda. Therefore, lambda is equal to h by mv. The above equation is known as deBroglie relationship, and the wavelength lambda is known as deBroglie.